If aliens can cross billions of miles of empty space, why can't they cross our radar? Hollywood tells us alien visitors slip in silently, cloaked ships, secret landings, erased memories. But the real universe isn't a movie set. It's ruled by physics, energy, heat, and light, and those things don't hide easily. Here's the uncomfortable question most UFO stories never answer. How do you travel across interstellar space without leaving any trace? No signals, no heat, no debris, no undeniable evidence. Tonight, we're not here to deny the possibility of life beyond Earth. We're here to ask something far more difficult, whether it's even possible for aliens to visit our planet without being detected at all. Now let's begin where every serious investigation should start. Before we go any further, let's establish something clearly. Questioning alien visitation does not mean denying the possibility of extraterrestrial life. In fact, modern science largely agrees that life elsewhere in the universe is plausible, maybe even likely. With hundreds of billions of galaxies, each containing billions of stars, the math alone suggests we are probably not alone. But belief in life elsewhere is not the same as belief in visitation. This channel approaches these questions the same way scientists do, through physics, engineering, and observation, not gut feeling or blurry footage. Organizations like NASA, the European Space Agency, and independent scientific programs such as SETI and Breakthrough Listen actively search the cosmos for signals of intelligent life. And so far what they've found is silence, not because we aren't looking, but because we're looking very carefully. Earth is already wrapped in an enormous detection net. We monitor space constantly, tracking satellites, asteroids, radiation bursts, infrared heat signatures, and electromagnetic signals. Astronomers can detect energy events from billions of light years away. Military radar systems can spot objects smaller than a car entering the atmosphere. This isn't speculation, it's routine. So the approach here is simple. If something can reach Earth, interact with our environment, and maneuver within our space, then physics demands it must leave evidence behind. Extraordinary claims don't require cynicism, they require extraordinary evidence. And with that foundation in place, we can finally confront the real problem. Not whether aliens exist, but whether visiting Earth without detection is even theoretically possible. Now that we've set the ground rules, it's time to confront the core issue head on. To believe aliens are visiting Earth without detection, we have to assume they can solve multiple fundamental problems simultaneously. Problems that even theoretical physics struggles to explain. Each one alone is difficult. Together, they become almost insurmountable. Let's break them down one by one. At this point in the discussion, a strange thing happens. The more we apply physics, observation, and logic, the harder it becomes to explain undetected alien visitation. And yet the stories don't go away. The sightings continue. The rumors persist. And the question remains lodged in the back of our minds. What if we're missing something? This is where most conversations split into extremes. Blind belief on one side, total dismissal on the other. But skepticism doesn't mean closing the door. It means standing in the doorway and asking harder questions. Let's examine the most common counter-arguments. Not to mock them, but to stress test them. This is perhaps the most popular explanation. The idea is simple. Advanced civilizations intentionally conceal themselves, avoiding detection while observing from the shadows. But hiding is not free. To hide, a craft must absorb or deflect energy, suppress emissions, mask heat signatures, avoid physical interaction with the environment. Each of those actions requires more energy, not less. And energy use creates signals. Even perfect camouflage doesn't eliminate waste heat. Even advanced materials can't make mass disappear. And even passive observation requires proximity, which means gravitational effects, electromagnetic interference, or environmental disturbance. You can hide a needle in a haystack. You cannot hide a bonfire in a snowfield. Another common analogy suggests Earth is a kind of cosmic wildlife preserve. Aliens don't interfere. They don't land openly. They simply watch. But observation at scale still requires infrastructure. Long-term monitoring would demand persistent platforms and orbit relays for communication, energy sources, maintenance, or replacement systems. Those platforms would still emit heat, reflect sunlight, perturb local space. Appear as unexplained objects following non-natural trajectories. Astronomers already catalog and track anomalous objects. Even unusual phenomena are scrutinized repeatedly. A hidden surveillance network operating for decades or centuries would not remain invisible forever. Silence becomes harder to explain the longer it continues. When the extraterrestrial hypothesis struggles, the explanation often shifts sideways into other dimensions, parallel realities, or higher planes of existence. But here's the problem. The moment something from another dimension enters our space, interacts with matter, affects consciousness, produces light, sound, or force, it becomes part of our physical system. And physical systems are measurable. Interdimensional doesn't mean undetectable. It simply moves the mystery somewhere else without explaining how interaction occurs without leaving traces. Changing the label doesn't remove the burden of evidence. This argument feels reasonable until you look at what we already detect. We can measure gravitational waves from black hole mergers, neutrinos passing through Earth, subtle wobbles in stars caused by orbiting planets, atomic vibrations at quantum scales. Our instruments aren't perfect, but they are extraordinarily sensitive. If alien activity were happening regularly, especially near Earth, it would stand out against natural noise, just as artificial satellites stand out from stars. The idea that everything escapes detection requires not just advanced technology, but perfect technology operating flawlessly forever. That stretches plausibility. So where does this leave us? We are left with a tension, not between belief and disbelief, but between possibility and evidence. The universe is vast. Life elsewhere may exist. Intelligence may arise in many forms, but visiting Earth without detection would require mastery over energy beyond known physics, perfect concealment with no waste, zero errors across vast timescales, no accidents, no leaks, no artifacts, and yet unexplained phenomena do exist. There are signals we don't fully understand, observations that challenge current models, events that don't fit neatly into known categories, and that's important to acknowledge. Mystery does not equal aliens, but mystery does remind us that science is unfinished. The real question isn't whether aliens are hiding perfectly. The real question is whether we're willing to accept uncomfortable answers, including the possibility that the silence itself is the message. The first obstacle is distance. The nearest star system, Alpha Centauri, is over 4 light-years away. That's roughly 40 trillion kilometers, and that's just the closest neighbor. Most potentially habitable systems are dozens, hundreds, or thousands of light-years away. To cross those distances in anything resembling a reasonable time frame, a spacecraft must move at a significant fraction of the speed of light. And that's where the problem begins. Moving mass at those speeds requires astronomical amounts of energy, comparable to the output of stars. Even hypothetical propulsion systems like antimatter drives, fusion engines, or light sails don't escape a basic rule of the universe. Energy use creates waste heat. This isn't a technological limitation. It's thermodynamics. No matter how advanced a civilization is, it cannot use energy with 100% efficiency. Waste heat must be released somewhere, and that heat radiates outward as infrared and other electromagnetic signals. Here's the key point. We already detect faint heat signatures from distant galaxies. We search for Dyson spheres, hypothetical alien megastructures, specifically by looking for unusual infrared emissions. So imagine a spacecraft powerful enough to cross interstellar space, slow down, maneuver, and enter a planetary system. That object would glow like a cosmic flare against the cold background of space. There is no silent mode for star-level energy use. If aliens were traveling between stars, space itself would betray them. Let's assume somehow they solve the energy problem. Now they have to reach Earth. Here's what most people don't realize. Earth is not isolated. It is one of the most closely monitored objects in the solar system. At any given moment, thousands of systems are watching the sky. Ground-based radar, space-based infrared satellites, optical telescopes, military early warning systems, asteroid and space debris tracking networks. We routinely detect objects smaller than a meter wide entering the atmosphere. Meteors light up the sky because friction ionizes the air around them, creating plasma trails visible across hundreds of kilometers. Anything entering Earth's atmosphere at high speed produces heat shock waves, ionization radar reflections. This is unavoidable. Even stealth aircraft designed to evade radar are not invisible. They are merely harder to detect, and only under specific conditions. And those aircraft operate inside the atmosphere at relatively low speeds using conventional energy levels. Now imagine a craft entering from space, traveling at extreme velocities, carrying immense mass, decelerating rapidly. There is no known way to do this without lighting up every sensor we have. And if the claim is that they land gently, then where are the launch and landing signatures? Where is the displaced air, the heat bloom, the sonic disturbance? Earth's skies are not empty. They are crowded, tracked, and logged constantly. At this point, some people say, aliens don't use normal physics. So let's talk about that. Faster than light travel, warp drives, wormholes, hyperspace, exists primarily in equations and science fiction, not experimental reality. Even the most optimistic models come with staggering consequences. Take the theoretical warp drive. It doesn't move a ship through space, it moves space around the ship. Sounds elegant, until you look at the requirements. These models demand exotic matter with negative energy density, energy levels rivaling planetary or stellar masses, severe distortions of space-time. Such distortions wouldn't be subtle. They would create gravitational lensing effects, radiation bursts, detectable anomalies in space-time itself. Wormholes have similar issues. Stabilizing one would require conditions so extreme that nearby stars would feel the effects. In other words, advanced physics doesn't make detection harder. It makes it easier. The more exotic the technology, the louder it becomes to the universe. If something were bending space-time near Earth, we wouldn't need blurry videos to notice. Our instruments would go wild. Let's assume the technology problem is solved. Now we reach biology. Deep space is hostile. It bombards travelers with cosmic radiation, solar radiation, high-energy particles. Over long durations, this radiation damages DNA, electronics, and materials. Shielding against it requires mass, lots of it, and mass increases energy demands, which loops us back to the first problem. Then there's time. Even at near light speeds, journeys could take decades, centuries, or longer from the traveler's perspective. That introduces problems of life support, psychological stability, genetic degradation, ecological sustainability. Some suggest aliens send machines instead of biological beings, and that's far more plausible. But machines still generate heat, emit signals, and interact physically with the environment. Robots don't get a free pass from physics. Whether biological or artificial, travelers cannot escape the constraints of energy, matter, and entropy. Now we reach the most uncomfortable issue. If alien visitation were real and ongoing, there should be side effects. Not rumors, not testimonies, physical evidence. Consider what we would expect. Repeated, consistent sensor detections, unambiguous materials not matching Earth chemistry, energy signatures, without natural explanations, artifacts left behind, intentionally or not communication leakage, even accidentally human technology leaks constantly. Our radio signals have been spilling into space for over a century. Our satellites leave debris everywhere. Our presence is detectable from orbit instantly. A civilization capable of interstellar travel would leave far more of a footprint, not less. And yet, despite decades of monitoring, trillions of observations, and thousands of scientists across multiple nations, there is no repeatable, independently verified evidence of alien craft operating on or near Earth. Absence of evidence isn't always evidence of absence, but when evidence is expected and none appears, that absence becomes meaningful. All of this leads us to a growing tension. If aliens exist, and if they are intelligent, and if they are technologically advanced, then why does their presence leave no measurable trace at all? That question doesn't end the mystery, it sharpens it. So where does all of this leave us? After stripping away the movies, the myths, and the assumptions, we're left with a quieter, but far more revealing picture of the universe. It may be full of life, it may even be full of intelligence. But visiting Earth is not the same as existing somewhere out there. To reach our planet, cross interstellar space, maneuver through the solar system, and interact with Earth without detection would require something close to perfection. Perfect energy control, perfect concealment, perfect execution, not once, but every time across immense spans of time. And the universe doesn't do perfect. Physics leaves fingerprints, energy leaves heat, motion leaves disturbance, presence leaves evidence. The more we understand how reality actually works, the more extraordinary the claim of invisible visitation becomes. Not because aliens are impossible, but because secrecy at that scale is. That doesn't mean curiosity should die, it means curiosity should mature. Instead of asking, do you believe? A better question is, what would we expect to see if this were true? And so far, what we see is not a hidden parade of visitors, but a vast, quiet cosmos that obeys its rules relentlessly. Maybe the real story isn't that aliens are secretly visiting us. Maybe the story is that intelligent life is rare, distant, or bound by the same limits we are, and perhaps the greatest mystery isn't why we haven't seen them, but what it means that the universe, despite all its immensity, remains so profoundly silent. Think critically, question boldly, and never stop asking why.